Okay, so let's do a very quick, it's just a very quick summary of those videos and what we saw and so on and so forth. So with the amount of radiation, if you've got an object at a certain temperature, okay, then the color is going to affect how much radiation it comes out. So this is the example of Leslie's cube. So what we see from this sort of thermal imaging camera of hot water into the cube like this, we see that we get lots of radiation coming out of that side, but less coming out of that side. And that is because white, shiny colors are poor emitters of radiation, dark colors are good emitters of radiation. And so the infrared camera gets confused by that image because it thinks that it's trying to work out how hot something is purely based on how it assumes that all things are at the same color. So it thinks that, oh dear, shouldn't be coloring that in. That's a bit of an accent. It thinks that this side is warmer because it's seeing more radiation, whereas we know that you put the same hot water in, they must all be at the same temperature. So, so this experiment, so what we get is that dark matte colors are good emitters of radiation, whereas we get whereas white or or shiny colors are poor emitters of radiation. And we saw that with the kettle and Leslie's cube and various things. So this different sort of level of so color can affect how much we get out. Similarly, we have stuff with absorption, and we saw that with this experiment here. We had the little color-based thermometers on the back of these discs that would tell us how hot the disc is against near a sort of like something which is giving off thermal radiation. Similarly, you could do similar stuff where you were in the sunshine. We could use thermal radiation from the sun, do the same thing. But what we find is that silver colors or light colors will rise in temperature more slowly than the dark colors. So at this point, we've got a color up here. So this disc, which is the dark one, is nearly at 65 degrees, whereas this one's about 35 degrees. And you can see that was quite a rapid sort of thing. And we get here is that dark matte colors are good absorbers of radiation. White, shiny colors are poor absorbers of radiation. And so in both of these instances, actually, so they are the same thing, just the reverse of each other. So what you're going to end up with is that things that are, if you want rapid temperature changes of things, either to warm up or to cool down, use dark colors. If you want it to be much slower, then you want to use whiter colors or silvery colors or things like that. So that is, and as we saw with the kettle, that can have a big impact in the length of time that something needs to be on if you're trying to warm something up. And what we'll look at next lesson, we'll bring all these three different phenomena together, and we start thinking about how we insulate various devices to minimize the sort of temperature changes. If we have something that's cold and we want it to stay cold, or we have something that's hot and we want it to stay hot, how can we bring together our ideas of conduction, convection, and radiation to enable that to occur? And there we go.